Hi guys, welcome back to YouTube channel Chemistry Live UGPG. So let's talk about how to determine the percentage of composition of glycerin in an unknown solution by the use of a Stalagmometer, that is surface tension method. So this will be highly beneficial for BSc and MSc chemistry students. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime, and help to learn others. So there is a disclaimer for this experiment. In this experiment, approximate data are used to give a flavor about the real experiment, calculation part and conclusion, and better understanding about the experiment. So if you carry out your own experiment, you will get your own original data, and it may happen that the result may vary from person to person. So the aim of the experiment is to determine percentage composition of glycerin in an unknown solution by the use of Stalagmometer, that is surface tension method. So what are the apparatus required? We need Stalagmometer, specific gravity bottle, measuring glass, small rubber tube with screw, pinch cork, and weighing machine. So these are the apparatus you need to recognize first. So how Stalagmometer look like? And then this is specific gravity bottle, measuring glass, and weighing machine. And here, as you can see, here is the mark, and here also at the bottom also here is a mark. So this is labeled as A, and this is point B in Stalagmometer. So what are the chemicals required? We need glycerin, distilled water, chromic acid, and alcohol. So let's talk about theory behind this experiment. So in this drop number method or surface tension method, the number of drops formed by equal volume of two liquids are counted first, and this number of drops and density of the two liquids are related to the surface tension of the liquid. So this is the equation. It says how they are related. If one liquid is water, so its surface tension and density are known, data are known. So we can find out the surface tension of other or unknown solution, that is glycerin. So now question arises, how to make the different percentage of solution. So we can make either by weight method percentage, or weight by volume percentage, or volume by volume percent. So let's talk about weight by weight percent. So this is the formula you have to use. Weight of the solute divided by total weight of the solution into 100. So suppose you are interested in 5% weight by weight acetic acid solution. So in that case, what you need to do, you have to take 5 gram of acetic acid, and you need to transfer the solution into the volumetric flask. And in the volumetric flask, the total weight of the solution should be 100 gram. So that means you need to 95 gram of water, so that solution will be 5% weight by weight. Similarly, for volume by volume percent, this is the formula you need to use. Volume of the total volume of the solute by total volume of the solution into 100. So for 5% volume by volume, you need to use 5 ml of acetic acid, and then you need to add 95 ml of water to that into the volumetric flask, so that the total volume of the solution is 100 ml. Similarly, in case of weight by volume percent, so this is the formula you need to use. Weight of the solute by total volume of the solution into 100. So that means you need to take 5 gram of acetic acid into the volumetric flask, and here the total volume of the solution should be 100 ml. So in that case, what you need to do, you have to convert this 5 gram of acetic acid into volume by using density equal to mass by volume, and the density of acetic acid is known, 1.05 gram per ml. So as a result, we get 4.76 ml of acetic acid. So that means to make 100 ml solution, we need to add 95.24 ml of water to this volumetric flask. So this is the standard procedure you need to follow. So first you need to clean this Stalagmometer with chromic acid and dry it. Then a small rubber tube having screw, pinch, cork is attached at the upper end of this tube, and the lower end of the Stalagmometer is immersed in distilled water, and you need to soak the water 1 to 2 cm above this mark A at the top. and the tube is so adjusted that 10 to 15 drops fall per minute. Then again this stalagmometer is clamped and water drops are allowed to fall, and start counting the number of drops. So when the meniscus crosses this upper mark A, then stop counting when meniscus passes the mark B at the bottom. And this process is repeated and the stalagmometer is rinsed with alcohol and dried. Then different percentage of composition of glycerin was soaked and number of drops were counted similar to the water. And this is the specific gravity bottle, so you need to take, and you need to take the weight of water as well as different composition of glycerin, so that you can find out the density of each composition of liquid. So this is the formula how the surface tension is related to density of both the liquid and number of drops of both the liquid. So we can, once we know the density of water and density of water and number of drops of water, we can find out the surface tension by using this formula. So here is the table you need to make, and here is the composition of solution like 0%, that is only water, then 5% glycerin, 10% glycerin, 15%, 20%, 25%, and this is unknown solution whose concentration or composition is not known. So in each case you have to find out the density of the solution, and density formula is mass by volume. And in each case you have to, in each percentage or composition of solution, you need to find out the number of drops. So once you know all these data, you can find out, put these values and here in this formula and get the surface tension. And here are some dummy data for number of drops from the stalagmometer for each composition. For water it is found to be 25, for unknown solution it is found to be 26 number of drops. And here also we found out the density for each composition of solution. For unknown solution it is found to be density is 1.02 and the surface tension is 70.50. So here you need to plot a graph between percentage of composition versus surface tension. So for each solution we know surface tension value and for each composition. So once you plot the graph, you will get a graph like this. And for unknown solution we know the surface tension value. So now you join this graph and you need to extrapolate from that point. So that will give you the percentage of composition of unknown solution. So if you plot the graph surface tension versus percentage of solution, you will get a graph like this. And for unknown solution, what we have got, that is unknown solution surface tension is 70.50. So now from 70.50 we draw the line and it crosses here, then you need to extrapolate here and it is found to be 2%. So in conclusion we can say, from the graph the concentration of unknown composition of acetic acid was found to be 2%. So please subscribe to our channel Chemistry Live UGPG. So this is a simple step towards e-learning, making life better. Thank you all for learning.